The B-1B Lancer hasn't changed shape in decades. Same wings, same engines. Yet the Air Force calls it new and ready to shock the world, not a new airframe. Everything behind the skin has been rebuilt, including communications, data links, defensive avionics, and digital architecture. Those systems have been transformed since the aircraft's nuclear mission ended in 1994. What hasn't changed is 75,000 pounds of payload and what the Air Force plans to do with it. 75,000 pounds. That's the number that defines the B-1B Lancer's place in the United States Air Force. No other United States bomber carries more conventional weapons in a single mission. This is not about the shape of the airplane or any new stealth coating. What matters is the raw capacity to deliver mass effects at speed. The B-1B's maximum payload, officially listed at 75,000 pounds, means it can haul a mix of guided and unguided bombs, cruise missiles, and emerging standoff weapons, further and faster than anything else in the current inventory. Speed is another headline figure that keeps military planners focused on the B-1B. The Lancer's 4 General Electric F101 afterburning turbofan engines, each producing 30,000 pounds of thrust, push the bomber past 900 miles per hour at sea level, about Mach 1.2. This is not a theoretical dash. The B-1B can sustain supersonic speed at low altitude, allowing it to cross hostile territory, strike, and exit before most threats can react. At altitude, it cruises comfortably near Mach 0.9, giving it the reach to span continents with aerial refueling. The crew of 4, the pilot, co-pilot, offensive systems officer, and defensive systems officer, work together in a cockpit that, while modernized in recent years, still serves the same core mission: to deliver a massive volume of ordnance with precision. Unlike fighters, which might carry a handful of smart bombs or missiles, the B-1B is built for what the Air Force calls volume precision. It is not just about hitting a single target with accuracy, but about striking dozens of targets in a single sortie. A typical loadout might include 24 joint air-to-surface standoff missiles for deep strike missions, or a mix of up to 96 smaller joint direct attack munitions, all managed by digital mission planning tools that optimize weapon-to-target pairing on the fly. This combination of payload, speed, and crew integration is why the B-1B remains a core part of America's long-range strike force. Its nuclear mission ended in 1994, but its value as a conventional bomber only grew as modern wars demanded the ability to deliver massed, precise firepower rapidly and reliably. The numbers, 75,000 pounds, Mach 1.2, 4 engines, 4 crew, are not just statistics. They are the foundation for everything that comes next: the weapons, the upgrades, and the evolving way the B-1B fights in the 21st century. Volume precision is the core of the B-1B's modern combat logic. Where most fighters launch a handful of precision weapons per mission, the B-1B is built to saturate the target area with dozens of smart munitions in a single run. This isn't just about carrying more bombs, it's about delivering coordinated, simultaneous strikes on a scale that smaller aircraft simply cannot approach. A single B-1B can load up to 24 Joint Air-to-Surface Standoff Missiles, JSSMs, in its internal bays. Each JSSM is a stealthy, GPS-guided cruise missile with a range of over 200 miles designed to hit high-value targets deep inside defended airspace. For perspective, a typical fighter like the F-15E might carry 2 or 4 JASSMs per sortie. The B-1B's standard loadout is 6 times that without needing to sacrifice fuel or range. In practical terms, one B-1B sortie can deliver as many precision strikes as an entire formation of fighters. freeing up other assets and reducing the number of aircraft exposed to enemy defenses. This approach is not limited to standoff missiles. The B-1B's weapons bays and pylons are designed for flexibility, allowing mixes of up to 96 smaller JDAMs or dozens of small diameter bombs, depending on the mission. The key is that the bomber's digital mission planning tools, upgraded through the integrated battle station, can pair each weapon to a specific target before takeoff, and then update those assignments in flight if new intelligence arrives. That means the crew can launch a precise, coordinated attack on dozens of targets across a wide area, all in one pass. The logic behind volume precision is simple. Overwhelm defenses, compress the timeline, and maximize the effect per sortie. In a high-threat environment, every minute counts. The B-1B's ability to deliver 24 JASSMs, or a full bay of JDAMs in one go, is not just a matter of brute force. It is a way to achieve strategic results with fewer sorties and fewer risks to aircrews. This is why the digital upgrades matter so much. Only with modern data links, automated weapon pairing, and real-time mission updates can the bomber manage and deliver this many weapons accurately. Volume precision is what keeps the B-1B relevant. It turns the aircraft's raw capacity into a force multiplier, making it a centerpiece of any large-scale strike plan. The numbers, 24 JSSMs and 96 JDAMs, aren't just statistics. They are a statement about what the B-1B brings to the modern battlefield, the power to hit many targets all at once, with the accuracy demanded by today's wars. Digital transformation began in earnest for the B-1B in 2012, when the Air Force launched the Integrated Battle Station program, known as IBS. This was not about changing the bomber's profile or adding new engines. It was a full overhaul of how the crew interacts with the aircraft. Over 8 years, engineers and maintainers retrofitted 60 B-1B aircraft, stripping out the old analog gauges and replacing them with high-resolution LCD displays, a unified mission data screen, and a streamlined architecture for navigation, targeting, and weapons management. The last jet rolled out in September 2020, marking the end of a cockpit era and the start of a new, fully digital workflow. With the integrated battle station, the crew gained a panoramic view of the battle space and the ability to manage dozens of weapons and targets with a few button presses. Real-time data links, automated mission planning, and a common software backbone cut down on workload and reduced the odds of error. This digital backbone set the stage for what came next, the Beast upgrade. On September 8, 2023, the first Beast-equipped B-1B took flight. Beast is a package of upgrades that turns the Lancer into a truly connected bomber. The checklist includes Link 16 tactical data link, modern encrypted identification friend or foe, secure satellite communications, improved defensive avionics, and expanded data storage. 23 more aircraft are slated for Beast upgrades by 2028, all building on the digital foundation laid by IBS. Together, these changes shift the B-1B from a Cold War analog platform to a networked, mission-adaptive strike aircraft, ready to operate in the fastest, most connected battle space the Air Force has ever faced. Survivability for the B-1B is built on a layered electronic defense, not just speed or altitude. The aircraft's protection starts with the ALQ-184 Electronic Warfare Suite, a jammer designed to confuse and disrupt enemy radar systems across a wide range of frequencies. Supporting this, the radar warning receiver scans for hostile signals and alerts the crew the moment a threat locks on. The Missile Approach Warning System uses infrared sensors to detect incoming missiles, triggering automated countermeasures when needed. Chaff and flares launch from internal dispensers, creating false targets to draw missiles away, while the ANAL E-50 towed decoy trails behind the aircraft, luring radar-guided threats off course. Digital architecture ties all of these systems together, allowing the crew to respond quickly and automatically to evolving threats. This is essential because the B-1B is no longer a large fleet. Only 44 operational Lancers remain, with just 2 more dedicated to testing. Each jet must be ready to fly at a moment's notice, and reliability is as critical as firepower. The average mission-capable rate hovers around 70%, reflecting the constant work by maintenance crews to keep these aging airframes combat ready. Every hour in the air comes at a cost, about $32,000 per flight hour, making efficient, dependable operation a top priority. For the B-1B, survival and mission success now depend as much on software, sensors, and the people who maintain them as on the jet's raw speed or payload. In the spring of 1999, NATO launched Operation Allied Force over Kosovo. The B-1B Lancer proved its value in a way that no other bomber could match. Just 6 B-1B aircraft flew, less than 2% of all coalition bomber sorties during the campaign. Yet those 6 jets dropped more than 20% of the total ordnance delivered by NATO air power. That means a handful of B-1Bs, operating alongside dozens of other bombers and strike aircraft, managed to deliver 1/5 of all the bombs in the entire air campaign. No other aircraft matched that ratio of impact to effort. Official Air Force Global Strike Command records confirm these numbers, and they remain a benchmark for what volume precision looks like in real combat. The statistic is more than history. It is proof that the B-1B's combination of payload, speed, and crew integration translates into outsized effects on the battlefield. When planners talk about the bomber's shock potential, this is the evidence they point to. 6 aircraft, 1/5 of the bombs, less than 2% of the sorties. The B-1B does not just promise massed firepower. It has delivered it decisively when it mattered most. Today, just 44 active B-1Bs form a smaller but digitally revitalized force, one that fuses proven payload with modern mission data and electronic resilience. The silhouette remains, but how it fights is fundamentally new. In a world where speed and mass still matter, this is where shock begins.